Now another nice question. If a is equal to 3, 1, minus 1, 2, show that a square minus 5a plus 7 is equal to 0, identity matrix. Now using this result, find a inverse. Okay, and sometimes it is written hence find a inverse. Okay, so we have to find a inverse using this result, not with finding the minors, cofactors or a determinant. Okay, remember, if you are in, suppose this question is in your exam and you are finding first, you are proving this part and then again you started to find determinants, minors and cofactors, then marks for the second part will not be given unless and until you are not using this concept. Okay, so now let's start it. Now first of all we have to prove a square minus 5a plus 7 identity matrix is equal to 0. Okay, so now we are having this as a square, we are having a as 3, 1, 3, 1, minus 1, 2, 3, 1, minus 1, 2 with 3, 1, minus 1, 2 minus 5 with a 3, 1, minus 1, 2 plus 7 with identity 2 by 2, 1, 0, 0, 1. Okay, we have to prove this part now. Now let's solve it. For the first of all, let's find the square. Now we are having 9 minus 1, 3 3s are 9 plus 1 with minus 1. Okay, 3 1s are 3 plus 2, then minus 1 with 3, minus 3 minus 2 and minus 1 plus 4, minus, sorry, positive, plus, negative, sorry, 15, 5, minus 5, it is minus 5 and 10, plus 7, 0, 0, 7. Okay, now further this becomes 8, 5, minus 5, 3, minus 15, 5, minus 5, 10, plus 7, 0, 0, 7. Now this is equal to 8 minus 15 plus 7. 8 minus 15 plus 7. Then 5 minus 5 plus 0. 5 minus 5 plus 0. Then minus 5 plus 5. Minus 5 plus 5 plus 0. And 3 minus 10 plus 7. 3 minus 10 plus 7. Okay, so this we got as now 0, 0, 0, 0. Therefore, a square minus 5a plus 7i is equal to 0 and this part is proved. This part is proved. Now, we have to, using this result, find a inverse. Okay, now using a square minus 5a plus 7 identity matrix is equal to 0, find a inverse. Okay, now let's check it. We are having a square minus 5a is equal to negative of 7 identity matrix. Then taking a common, we are having a minus 5 identity matrix with a, because when we are taking a common with the numeric value, then definitely we have to write it identity matrix, because when this is matrix, this should be also matrix form. Okay, is equal to minus 7 with identity matrix. Now a minus 5i, A inverse is equal to minus 7I with A inverse. Okay, pre-multiplying by A inverse. Now A inverse is equal to, it was 7 A inverse minus 1 by 7 with A minus 5I. Okay, so this is the A inverse. Now let's find this part. Now this is equal to minus 1 by 7 with, we are having now A is this one, 3, 1, minus 1, 2, minus 5 with 1, 0, 0, 1. Okay, remember, to the matrix we can write in this manner also. Okay, so this further becomes minus 1 by 7 with now 3, 1, minus 1, 2 with 3, 1, minus 1, 2, minus 5, 0, 0, 5. This is equal to minus 1 by 7. Now 3 minus 5, 1 minus 0, minus 1, minus 0, and 2 minus 5, that is minus 3. So we are having minus 2, 1, minus 1, minus 3. Okay, so now finally A inverse is equal to minus 1 by 7 with minus 2, 1, minus 1, minus 3. Okay, so we have not calculated the cofactors for finding the inverse. We have used this equation and it was proved that it is equal to 0 unless and until this is not equal to 0, we can't find A inverse.